Good evening, everyone. Welcome to week 5 of 6200/8200 Principles of Information Security and Privacy. This week, I just kind of want to start jumping into firewalls. Up to this point, we've covered just a brief introduction of information security as well as cryptography and authentication. So I kind of wanted to go over some of those basics right off the bat, and just sort of we could start talking about encryption. We could start talking about why security is in place for to protect confidentiality, integrity, and availability. And we want to talk about how authentication works. And we want to kind of hit these basic principles before we start talking about how. Okay, so how do we use encryption? How do we protect the confidentiality, integrity, and availability of the information that's traversing our network on the internet and as well as the internal network? So at this point, we've been kind of handling some very basic things. And so now we're kind of going to start jumping into the meat of it. We're going to talk about firewalls, and we're going to talk about intrusion detection and prevention systems. We're going to talk about trying to secure an organization. We're going to start talking about wireless security. We're going to start talking about let's talk about some practicality. And this is going to start coming into play when we look at some of our hands-on activities that's coming up in another week. So just briefly, there is a video that I have uploaded. It's a reference video about how TCP IP packets traverse a network. It's a pretty neat little 3D animation video. It's listed there. It's the first one in the modules. This is not a networking class. I'm not going to dig down too much into how networking functions. There is a network security class that is pretty good. It starts digging in down to the weeds a little bit more. This is more of an introduction to all the different concepts that are available out there as far as security is concerned. And again, this just kind of touches on things, give you a little taste, give you a little moment to start digging into these concepts and what they can mean for your own practical application when it comes to your network. So please, if you haven't watched it, go ahead and watch the TCP/IP explained video that is listed in Canvas. And otherwise, we're going to go ahead and jump right in here. So before we start talking about firewalls, let's talk about some examples of types of attacks that we typically see on a network, either from the internet going into a network, or we start talking about stuff that we do see on the inside and why we need firewalls, why they're in place. So let's talk about this one right here, IP spoofing and flooding. So you have X, it establishes a TCP connection with B, assuming A's IP address. So basically what you got here is you have A wanting to connect to B, wanting to talk to B, but instead of that happening, you have X. We call this Alice and Bob, and then you have Eve down here. So Eve attempts to spoof one of the two IP addresses between the two here trying to talk to each other, and tries to either intercept traffic, creating a man-in-the-middle attack, or they try to actually try to get cause a flood attack. A lot of times you'll see something what's called a Smurf attack when it goes like a ping attack. So basically what happens is normally when you send out a ping request, which is also kind of ICMP request, you'll send this request out, hey, basically pinging the client or the server or whatever, hey, are you up? And then you'll get this reply. So what an attacker will try to do is that it will send this echo request to a broadcast address from the victim. So it will send out just a massive load of different IP addresses, all trying to hit this victim all at the same time, effectively, causing it to go down, or actually causing a problem with availability. So actually doing a denial of service. So the Smurf attack, generate a ping string, basically what I just said, an ICP request to a network broadcast address with a spoofed source IP address to a victim host. Every host on the ping target network would generate a ping reply all towards the victim host. Basically what I just said. So the attacker will spoof this person, the victim's IP address, that they're sending these ICMP packets to a large number of broadcast IP addresses, and then all of a sudden they get this reply all at one time. So if you think of it like this, the best way to look at it is, I know this seems like a kind of silly type thing to think of, but think of it like this. The attacker goes into a local town, and this goes back to referencing our city wall analogy that we used at the very beginning. He'll go into a local town and say, hey, guess what? This guy over here is talking trash about your town. He's saying you're this and you're that. Well, all these people get angry. They don't go attacking the attacker. They go attacking this guy. All right. So basically, that's in a very stripped down version of it. That's basically what an ICMP request and reply is happening there with the Smurf attack. So essentially what that is. So an amplified ping reply stream can easily overwhelm the victim's network. You also have something like a Fraggle and a ping pong exploit UDP in a similar way. So that it's kind of the same thing that we're just talking about here. To kind of put this in a little bit better perspective, this is what's called a distributed denial of service attack. So you have an attacker here, and they'll have 3 master servers. And then they'll have all these zombies here at the same time, and they'll start sending all these requests to the victim. Well, because this attacker has control of these masters, and these masters have control of these zombies, these requests, you can see how they can tend to overwhelm a particular victim. This becomes particularly prevalent when it comes to state-run governments, or state-run networks. So one will try to overwhelm another by sending these types of requests and trying to bring down a network, or bring down corporate attacks. Do this kind of same thing. Hey, your competitor is doing really well. We want to try to bring down their stuff. So you can actually rent space. Yeah, as strange as this is, you can actually rent time with an attacker and actually try to create a denial of service. And corporations do this to each other. So these are another type of attack. You have a Smurf attack. You have a distributed denial of service attack. You have what's called an amplification attack. So you have an attacker here, and he will have control of 2 compromiser hosts, and he'll send these small requests to this particular public server that's been that'll be abused, and then the server will send these massive, huge requests in size to the target. So that, even if the attacker has control of these small hosts, this isn't going to really do anything. But if they can find an abused server that can that has more power and more computing power, and send these amplification attacks to the target in an attempt to overwhelm it, that's what they'll do. So this is just sort of kind of a little taste of, of some of the different attacks that are out there, and you're asking yourself right now, what in the world does this got to do with firewalls? Well, I'm glad you asked. So we're going to jump right in here. So what you have here is, so these types of attacks, they do happen on the internal network, but they do also happen from the external. So you have this external network where these types of attacks can happen. You have like a distributed denial of service, whether it's a state government attempting to take on another state government or another corporation, or cause an amplification attack, or you have spoofing attacks, or whatever it may be. On these networks, it is just stupid if you don't have some form of firewall protecting your network. Otherwise, it would be like like I've talked about before, like the city wall analogy. It would like be a city, that has no walls around it, that can't protect itself from outside forces. It can't protect itself from an attacking army or whatever it may be. So you have to be able to protect your resources, and this is what it comes down to in IT security. Those of you that are developers, or those of you that are into networking or whatever it may be, networking, you're trying to make sure that people can access resources. Developers, you're trying to create resources. Well, what is security trying to do? We're trying to protect resources, and we do that by doing using things like firewalls. We want to protect, what we have on the inside. So, what's the ultimate firewall? The ultimate firewall is what's called air gap. Is just not be connected to the internet at all. And although that may seem logical in a lot of instances when it comes to certain types of network, it's just not very practical because, for all intents and purposes, your people at work, at your company, need to be able to access the internet for different things. Now, it may be an instance, if you have something like a nuclear power plant or an electric company or something like that, then obviously it needs to be air gapped. Some of those internal systems that control the regulation of the nuclear power plant, their resources and facilities. Obviously, you don't want those exposed to the internet, so you would air gap that network. That would be a separate network within your environment that is protected. In addition, you're going to have things like certain types of credit card processing terminals. So, for instance, case in point, let's say you have certain terminals that take credit card information and store credit card information. Well, you don't want that information going out to the internet, and you don't want it exposed to the internet. You don't even want it exposed to your internal networking people. You want that kind of set aside. You want it air gapped from everybody else. And we're going to talk about a little bit about demilitarized zones here shortly. But yeah, the ultimate firewall would be air gapping a system altogether. This is a neat little network. The NSA devises radio pathway into computers. This is an extreme example of of an air gap network being compromised. If anybody are looking for this particular article, it was in the New York Times in 2014. Some additional reading if you like. But let's stay on topic with a firewall. So what is a firewall? It's a wall constructed to prevent the spread of fire. Okay, so if many of you go into like a mall or you go into a particular a particular building where you have a maintenance hallway or a something like that, you'll always see like firewall rated 2 hours, 3 hours, whatever it may be. It's a wall that is built specifically to prevent the spread of fire and to withstand a certain amount of heat. Well, that's exactly what a firewall is for security. It's there to withstand and protect your internal resources for as long as possible. So the internet firewalls are more the moat around a castle than a building firewall. So just like we were talking about the analogy, again, I keep using it over and over because it just makes sense. So it's a controlled access point. So you're probably asking yourself, well, how do we control this firewall? What are the different types of firewall? How do we prevent this from happening to us? Well, let's dig into a little deeper. What does a firewall do? It's responsible for controlling access among devices, such as computers, networks, and servers. All right, so basically, there's not just necessarily an internal firewall. There's also an external firewall that's helping to prevent people from getting in, but there's also internal firewalls. For instance, case in point, you don't want people, let's take UNCC, for instance. You don't want your student population being able to access human resources or accounting or, certain things. So you may have multiple internal firewalls that help to protect your resources on the inside to kind of help segment, and that's a big buzzword these days and when it comes to IT security, and is segmenting off your network using firewalls. So the most common deployment is between a secure and insecure network. So the main functionality of a firewall is to allow block network traffic. However, advanced firewalls may provide other functions. So what are we talking about here? Basically, what we're saying is that you'll have an internal, and again, this is using the example of the internet and the internal network. So you have this firewall here that's preventing the people from the internet accessing your internal network. But at the same time, let's just pretend this over here is another segment of your internal network. Over here is all your servers and workstations and routers and all that information that helps students to connect to the internet and connect to resources on the internal network. But you don't want those people being able to connect to your human resources and accounting, so you'll have this firewall in place to help to try to prevent. This will be a untrusted environment, and then the people that are on the inside that work for the university and attempt to bring people on and do payroll and everything like that, that is a trusted network. All right, so what can firewalls actually do? They can restrict incoming and outgoing traffic by IP addresses, ports, or users. So they can also block invalid packets. So again, using the analogy from the students and the internal network, hey, this student over here is attempting to access some resources on this side of the house. You know what? I see that user, and that user is not supposed to be accessing anything over here, so denied. And then at the same time, oh well, this person is coming from this particular source IP address, and they're not supposed to be able to access stuff over here, so denied. So that's what firewalls do. All right. So let's talk a little bit about firewalls in action that provide secure connectivity between networks, internal and external, varying levels of trust used to implement and enforce a security policy for communication between networks. So again, like I was just using the analogy before, here's a trusted network here. All right, the intranet, the untrusted network, the internet. Untrusted users, you don't know these people. These are people from the outside. They're trying to get into your internal network, access your resources. And you have a firewall / router here. And then you have something what's called the demilitarized zone, the DMZ. These are servers that, okay, you want people to be able to access your web servers, your web applications, but you don't want them to be able to touch your internal network. So it will, the firewalls will see this information come in. Okay, well, I see that you're trying to access our web application. Now, although everything is behind the firewall, I see where you're trying to get. You're trying to get over here. Well, that's okay. I understand that. You can access that information. That's fine. So it'll see that traffic and then divert it over here to the DMZ where it can be properly processed, and you can access the website or the internal systems just here. But you can see is this network is not connected to this network. So that's where the difference is. It knows that it looks at the source IP address, it looks at the destination, it looks at what you're trying to access, and it says, okay, you can access this, but not this. So that's how a firewall works. They're convenient. They give insight into traffic. They log a lot of that traffic. So if you have a breach, if you see someone is trying to attempt to get to a part of the network they're not supposed to be, then that will, it'll stop that. But it'll also log that. So you can say, you know what? I keep seeing this traffic coming from these IP addresses over in, I don't know, Antarctica or Indonesia or whatever it may be. Something's wrong about this. We need to block this stuff. Or you can actually, there's a difference between what's called blacklisting and whitelisting. And for all intents and purposes, whitelisting is the way to go. Whitelisting basically means you block everything except for what is allowed through. Now that's not always practical, but when it comes to your internal network or your customer, that is the way to go. You want to just block everything and only let certain things through. It's also, you have network address translation. So what does that mean? Network address translation means that you have a certain type of IP address for your internal network and a certain IP address for your external network. So there is a translation. So you will have, if any of you have home routers at home and you type in what's my IP, it will generally give you what your externally facing IP address is, what the world sees as far as your IP address. Now, if you go to a command line and you type in an internal IP address, you type in ipconfig or ifconfig, depending on if you're on a Linux system or a Windows system, it will give you your internal network, which would generally be something like 192.168.1, etc. So there's doing a network address translation. So someone wants to, if you want to access your home network, and there is a translation, you can access that external IP address and it will know exactly what you're trying to access on the internal network. Encryption, that's also included in a lot of firewalls these days. Software packages, dedicated firewall devices, comprehensive unified security appliance, so stuff like firewalls, VPNs, intrusion detection systems. We're going to hit that as we're moving along a little bit more. All right, firewalls cannot protect traffic that does not cross it, routing around the internal traffic. So again, this is what it pertains to externally facing firewalls. So if there are firewalls if there's traffic that or servers that you're trying to access, and they do not have to go through the firewall, you're basically being able to route around that traffic. Or if there is not an internal, if your internal network is not segmented, then obviously that internal traffic is just going straight to the other servers. It's not hitting the firewall and it's not protecting you. A lot of firewalls are misconfigured, and this is something that comes into. It's really important to audit your firewall. Basically, there are rules that you set with a firewall. Hey, you can do this, but not this, and we're going to hit that as we move along a little bit deeper, and you're going to see that here in a few minutes. Services through the firewall introduce vulnerabilities. Just because there is a service that goes through a firewall, there may be vulnerabilities with that particular service that can actually pass through that firewall because it's a legitimate service, but there may be vulnerabilities in it. Insiders can exercise internal vulnerabilities. Again, this is something we were just talking about a few minutes ago. All right. So let's look at some access control features as far as the internet is concerned. So here's the internet. Oh, big bad alert! 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 It's so bad. You need to have a certain level of access control. Where can these people? And again, we were just talking about this a few minutes ago. Where for these people from the internet? Are they allowed to access? Can they hit the web server pool, or can they go to the corporate network? All right. So if you have these people that are coming from certain IP addresses, or they do have some type of authentication, some type of username and password, what does that username and password actually allow them to access? Is it the corporate network, or is it just the web servers? What can they see? All right, so we just hit a brief, quick look at what firewalls are and how they function. Before we start digging into the firewall types, we're going to go ahead and end this video. And we're going to kind of break it up so you can watch this video and then come back and look at a different one. That way I'm not sitting like continuously going. But we're going to go ahead and close out this one, and we're going to start the next video. All right, and that'll be it for this one.